Welcome. In this video, we are going to find the second derivative of f of x equals x squared minus 3. And in this version, it's from example 2. In your version of the notes, it might be different, but either way, it will be from a previous example. And in that example, we figured out that the first derivative is equal to 2x. So now let's go ahead and use the limit definition to find the second derivative. That is, f prime prime of x is equal to the limit as h approaches 0 of f prime of x plus h minus f prime of x divided by h. On this side here, let's work out f prime of x plus h is equal to 2 times x plus h is equal to 2x plus 2h. Now let's replace f prime of x plus h here with this quantity. So we have the limit as h approaches 0 of 2x plus 2h, and I'm going to include parentheses even though I don't need them, just to emphasize that this is f prime of x plus h. Then I'm going to subtract our original function, which is f prime of x, which is 2x here. And again, those parentheses are just for emphasis, and that's divided by h. So this becomes the limit as h approaches 0 of 2x plus 2h minus 2x over h. Notice that we have a positive 2x, and we're subtracting 2x from it, so that's just 0. So in our next step, we end up with the limit as h approaches 0 of 2h over h, which is just the limit as h approaches 0 of 2, which is just 2. In case that was too quick for you, here I have h over 8. That's just 1. And the limit of a constant is always just the constant. So this tells me that f double prime of x is equal to 2. So now to find the third derivative, let's write the limit as h approaches 0 of f double prime of x plus h minus f double prime of x divided by h. Let's work out what this is just on the side here. F double prime of x plus h is just going to equal to 2. And if you're wondering why, well, there is no x here. None. Anywhere. So there's no x for me to say plug an x plus h into. So that's just 2. And then what is the second derivative? Well, we already know that's 2. So this is 2 minus 2 over h. That's just the limit as h approaches 0 of 0 over h. And that's just 0 since any number below 0, any number. So if we have a numerator of 0 and something else in the denominator, that always equals 0. Of course, this denominator cannot equal 0, since 0 over 0 would not be correct. And it might be a good time, if you have an iPhone, to ask Siri what 0 divided by 0 is. Okay, so this tells us that the third derivative of x is equal to 0. Now let's double check if our answers make sense. And in order to verify whether or not our answers make sense, open up GeoGebra on your calculator. And we're going to verify these graphically by discussing the interpretation of what a derivative actually is. So you're going to want to type in f and then in parentheses x, f of x equals x squared, then minus 3. That's our original function. And then let's type in f prime of x. So actually, I'll just type this in as f prime of x. And there we go. So GeoGebra graphed that for us. And this is definitely the line y equals 2x. Since if you notice between this point and this point, there is a rise of 2 units and a run of 1 unit. So that slope is definitely 2. Next, let's go back in here and type f prime prime. Now that we have that first derivative, let's examine what this means. So the slope of this line from any 2 points that we pick is always going to be the same. It's always going to be a rise of 2 over a run of 1. So the change in y is 2 for every 1 change in x. That tells me that the slope of this orange line, which represents the first derivative of our function, is constant. This is why when we got our second derivative, as you'll see here, when I type in f prime prime, you get a horizontal line because that's the line y equals 2. And that tells me that the derivative of this orange line is this constant. Now, what is the slope of that blue line? Because that blue line represents our second derivative. That blue line is a horizontal line, so it has a slope of 0. So when we graph, say, the third derivative, f, and then 1, 2, 3 primes, you get a line that lies along the x-axis. That tells us that indeed the slope of that blue line is 0 throughout. So indeed our calculation that we got using the limit definition of the derivative telling us the third derivative is 0 is also correct. I hope this video was helpful.